Hello. In this video, we'll be looking at something called position vectors. Now, let me draw this grid here, x and y, and let's say I have the vector a, which is, let's say 3i plus 2j, right? Now, obviously, 3i means effectively 3 on the x-axis, right? So 3i there. And then 2j, that's 2 on the y-axis, right? So it'd be up here. Because again, remember, the I is basically the x component and the j is the y component of my vector. And so then that's our point here. And so we draw it from the origin there. And there's our vector A. Okay. Now, this is a vector, but actually this is what we call a position vector. A position vector is basically just a coordinate, right? Think about, as another example, let me draw another grid. Say down here, I'll draw a smaller one. Obviously, say for example, we had the point, say, 4, 2, right? Just a normal XY coordinate, right? Now that's a 0.42, but that point is actually relative to an origin, right? So we're measuring that, from the origin. So it's 4. So from the origin, it's 4, then along the x-axis, then 2 up, right, on the y-axis, right? So when we reference coordinates, we're basically starting from the origin, right? Our origin is sort of like our starting point, and then we end at the coordinate there, which we want, okay? Vectors has pretty much the same thing, right? If we draw in a vector starting from the origin, now remember the origin in vector form, obviously we know it's 0, 0, but as a vector, it's going to be 0, 0 as a column, or we could say that as 0i add 0j, right? So the origin is the exact same thing, but as a vector, then it's a vector where we start from the origin, right? And so at the point at the end here, it's basically the coordinate, right? It's 3, 2 effectively, but instead of 3, 2, in that way, it's column 3, 2. And so that is a position vector. Position vector in vector form is basically just a coordinate, right? It's called a position because it's given the position, right, of a particular point, right? That's what effectively what it's doing. In vector form, a position vector is measured or starts from the origin, okay? Pretty much, so it's essentially a coordinate, right? Which obviously we've seen since like key stage 3 or earlier than that. Coordinate that we know and love, right? In an XY grid, the vector version of that is a position vector, okay? Position vector just tells us the point, the coordinate or the position of a point from the origin, okay? Right, okay. So then, that's a position vector then. Now, let me consider then the vector. Let us consider 2 points, right? A and B, right? Okay. So the vector AB is what I've drawn there, right? I can reference this as vector AB, right? Hopefully you can see that. The vector AB here is saying the vector or the path from A to B. And I've drawn that here, right? Just the vector, the line between point A to point B. That is the vector AB. But then if I then consider this position vector, if we have an origin, right? Origin 0, 0, I'll call O. We can actually then make a triangle, right? In this way. So then what we have as well then is the obviously A and B are points, right? so I can consider the position vector from the origin to point A as there, and the position vector from the origin to B. So OA, the vector origin to A, is the position vector of A, okay, of point A. And likewise, the position vector of the point B on my diagram is the position vector of point B, okay. So then the vector connect from the origin to a point A, that is OA, that is the position vector of A, and likewise for B, OB is the vector, OB is the position vector of B. So it's basically the coordinate, right? The coordinates of A and B, okay? And so why am I drawing this then? Well, if we go back to, I'll do it down here. If we go back then to our vector A to B here, well, actually, we can go and utilize position vectors as well. So if we want to start at point A here and end at point B, so the vector A to B again, we can alternatively go that way from A to O and O to B. Okay, and that is, remember when we looked at in the starter vectors, that is the triangle law of adding two vectors, right? This is the triangle law. Okay, so this is AO, so the vector A to O, and then the vector O to B. Okay, and so this is a way then, if we have the vector between any 2 points, A and B, we can alternatively use position vectors using the origin to say that the vector from A to B is the same as the vector from A to O, then O to B, as we can see in this triangle, okay? And then, well, A to O, well, I know O to A is that way, right? O to A, but I want to go the other way. I want to go A to O. So it's going to go the opposite way to OA. So remember then we do the negative to flip that direction. So negative OA, add OB, okay? And then if we just rewrite this then, ever so slightly, AB then, any vector A to B, any point A, any point B, the vector from A to B is alternatively, we could say, using position vectors, the position vector of B minus the position vector of A. And that is another way of expressing a vector between 2 points, okay? And we will be using this throughout this section, and you will need to know we can sort of decompose or express a vector in this way in terms of the origin, okay, in that way, okay, and it all stems from this triangle here, okay. Okay, so hopefully it made sense, and so that's what we're working with, right? So the whole essence is that a direction vector, I'm sorry, a position vector is basically a coordinate. So we start from the origin and then we go to our point, okay? And so there we are. Okay, so we got this first example then, and I think this example really does show the idea of a position vector really well. I think it's a nice example. So let's have a look at it. So we're told the points A and B in the diagram has coordinates 3, 4. So A is 3, 4, and B is coordinate 11, 2. Okay. Find in terms of I and J. First of all, the position vector of A. So the position vector of A is basically the vector coordinate of A, right? So it's from the origin to A, right? That's the position vector of A, OA. So O to A. So remember, again, a position vector is just from the origin to my point. So it's this vector here, right? It's this vector here. So really, it's just going to be 3, 3, 4, right? So it's going to be 3, 4. And then in I and J, that is 3I and 4J. And there we are. So very simply then, the position vector of A is just the coordinate of A, but in terms of vectors. So the X part and the Y part of the coordinate, okay? That is all it is, okay? Now for part B then, it says the position vector of B. So again, very similarly now, for B, what the vector from O, the origin to B, OB. So that's effectively the coordinate of B. So that's going to be then 11, 2, which will be 11i add 2j. Okay, so that is position vectors. It's just a coordinate but as a vector. Okay, and there we are. Then part C then says the vector A to B. Now A to B then is not a position vector because it's not from the origin, right? It's from point A to point B. So 2 different points there. So it's going to be this vector here, right? It's going to be from A to B. Well, I can't find AB directly, but I know what OA and OB is. I can use the triangle, right? If I want to go from A to B, I can also go from A to O, then O to B. Okay, so AO and O to B. Okay, well, AO then, again, that's the opposite way around of O to A, right? So it's going to be the negative of OA, add OB, okay? And so therefore then, minus OA is this. It's minus 3i, add 4j, add OB, which is 11i, add 2j, and then I just need to add the I and j's. And then I get, well, minus 3i add 11i is 8i. And then minus 4j add 2j is minus 2j. And there we are. That's my vector A, B. Okay. There we are. Okay, now we got this example. So we got OA is 5i minus 2j. And AB is 3i add 4j. Then we want the position vector of B. So that's going to be the vector OB, right? From the origin to B. Right, so again, I can draw a triangle if you want. So again, if I have the point A to point B, again, so that's the vector AB there. But obviously also, if I then consider the origin, right? So connect point A to the origin, and then the origin to B, so the point B as well. Then to get from O to B here, right, O to B, I can alternatively go from O to A, then A to B, right? So OA, add A to B, okay? And then I could just add my 2 vectors then. So OA is 5i minus 2j, add AB, which is 3i, add 4j. Then if I add the i's and j's, well, 5i add 3i is 8i. And minus 2j add 4j is plus 2j. And there we are. So that's the vector B, or the coordinate of B, which we could then say is 8, 2. Okay. So the x part is 8 and the y part is 2. Okay. So that'd be the coordinate of B alternatively. But they've asked us to give the vector. So there's my answer. Right, okay, so then it says for part B, find the exact value of this double bar OB, right? So remember from last time, this bar represents the magnitude or the length of vector OB. So to do that, that's going to be the square root of the x part, so it's going to be 8 squared, add the y part, which is 2 squared. And so if I do that in a calculator, I get 2 root 17. And there we are. And so there we are. So again, we covered the magnitude, this idea last time. We just square root the x or the I and the j parts in this way. Okay, we square root the the I part squared and the j part squared. Okay. Now, I do want to highlight a little shortcut when you at this point. Hopefully, you sort of got an idea now. We can construct a triangle, right, including my 2 points A and B and the point O. Okay. So alternatively, instead of just trying to do the triangle every time to visualize, well, this is what's going on, right? The triangle is what's going on. I do want to kind of pick up the pace with these sort of questions with the position vector. For example, if you have the point AB again, the vector AB, so if you have any vector between 2 points A and B, I can immediately then just decompose it instead of into the vector OB minus OA. okay? So you can think of it as the position vector of the second point minus the position vector of the first point, okay? So very quickly then, I can decompose any vector like this into these two position vectors, okay? And again, you can confirm that by looking at the triangle here. A to B is the same as O to minus OA add OB, okay? But without doing the triangle every time, I can just sort of remember this sort of rule, okay, with position vectors. Okay. Now we've got some exercises then. So we're given the point A with position vector 4i minus 5j. So that means the vector O to A then, because again the point A is from the origin to A. The position vector is 4i minus 5j. And the point B has position vector 6i plus 3j. So that means OB then, the position vector of B again is O to B, which is 6i add 3j. Find the vector AB. So again, at this point, I just want to just get right into it. So A to B then, in terms of the position vectors of A and B, right? I can then say it's the second point, so OB minus the first point with OA, okay? Again, I can visualise it if I did a triangle, which I did earlier, but I can just get into it now. So then OB is 6i, add 3j, take away OA, so it's going to be take away 4i. So take away 4i minus 5j, so that's OA. So then I can just sort of collect the I and j's. So 6i take away 4i is going to be 2i. And 3j take away negative 5j is a double negative, so it'd be positive. So 3j add 5j would be 8j. And there we are. So that's the vector AB. Cool. Then for part B, we then need to find the magnitude of AB. So again, pretty standard at this point. So that's going to be the root of the two components squared. So it's going to be 2 squared and 8 squared, which again would get me 2 root 17. And there we are. Okay, this is a bog standard exam question they love to ask. Okay, it might be fairly simple, which you practiced, but it's very common exam questions. So do make sure you know how to answer this fairly comfortably. Okay, we will see an exam question at the end of this, which is pretty much the same thing. Okay, so make sure you understand what I did there. Okay, right. Okay. Okay, now we're given this question, a bit more interesting. So we're told the point A lies on the circle with equation x squared and y squared is 9. Interesting. Now we've got x and y's, sort of like the normal sort of, coordinate grid, right? X and y. We're given the vector OA is 2ki plus kj. We need to find the exact value of k. Now, it's quite interesting again. So we're sort of in like the normal like xy grid, right? With like, what would this be, right? An equation of a circle, right? Obviously it says it there. But it's going to be a circle, centre, origin, radius 3. Right? But then we're also mixing this normal xy business with vectors. When we're mixing vectors and xy's together, it's quite interesting that is. But this goes back then to what I spoke about at the start, right? Where position vectors are basically just coordinates, right? So we can go into the two sort of worlds together. We can go from the vector world to the xy world by just utilizing that the position vector is just the point, it's the coordinate. So this is telling me the coordinate of A then, if we're given this position vector of A, is simply, well, the x part is going to be 2k and y is going to be k, okay? And there we are. So then we can, now that is just xy coordinates. So now I can sort of do stuff with this equation, right? Well, I can substitute that in then, because then x is going to be 2k, y is going to be k. So therefore, if I sub the point 2k, k into x squared and y squared is 9, I then get that x squared is 2k all squared. and y squared is k squared. That equals 9. And then it's just an equation for k, right? I can solve. If I expand this, I get 4k squared and k squared is 9. So then 5k squared is 9. Therefore, k squared is going to be 9/5. So then k is going to be plus or minus root 9/5. And that will go to 3 root plus or minus 3 root 5. Oh, plus or minus 3 root 5 over 5. Okay. And so there we are. The question doesn't tell me anything about k, if k is positive or negative. So that is the two values of k then. Okay, again, the question is a bit misleading. It's from the textbook. They're not always written perfectly. The mark scheme does say those two values of k. But there we are. So hopefully this question hopefully does emphasise that literally the position vector of a point A, say, is just a coordinate, right? Hopefully you can see how we jump from the position vector OA to the coordinate of A by literally the X and the Y parts matching, okay? And then it's just from there, okay? So hopefully that made sense, that question. Now we got this question here. It's a challenge question. I don't think it's that bad, but it uses the same idea that we just talked about. So now we're told the point B lies on the line. Point B lies on the line with equation 2y is 12 minus 3x, and we're given that the magnitude or the length of OB, the vector O to B, is root 13. Find possible expressions for the vector OB in the form PI and QJ, so I and J. So again, a quite interesting question. More of a difficult question. Obviously, it's a challenge question. But again, we're told the point B lies on this line here. Well, then we can, if 2y equals 12 minus 3x, then therefore y equals, if I divide by 2, it's going to be 12 over 2, which is 6, minus 3 over 2x. Okay? And so then that's telling me then, if I have an x coordinate, then the y coordinate is 6 minus 3 halves x, right? So, okay, so B has a coordinate xy, right? Just a general point xy, I need to find that coordinate. Now I'm given that also the length of OB is root 13. Well, again, therefore the position that if B has the coordinate xy, then O to B, so if we're going from the coordinate in xy into now the vector OB in terms of I and j, that's just going to be xi and yj, right? So the same x and y parts, okay? So then I can then compute the magnitude of this, right? Obviously it's going to have x and y's in, but that's fine at this point in time. So we know then that the length of the length of the magnitude of OB is going to be then the square root of the x and the y parts squared. So it's going to be x squared and y squared. And then that's going to just equal then root 13. But then we can square both sides to get rid of the roots. So therefore x squared and y squared is equal to 13. Right. But we also know then that that y is equal to minus 3 halves x add 6, right? So then we got simultaneous equations, right? And then it's just a case of solving this, right? So then I can substitute y from the second equation into the first one. And then we're going to get that x squared add minus 3 halves of x add 6 all squared minus the 13 equals 0. So move the 13 here to the other side to equal 0 to get an equation. So then I just need to expand the bracket then. So I'm going to get x squared. Then if I expand this bracket, well, minus 3 halves x times another minus 3 half x. It's going to get me plus 9 over 4 x squared. Then minus 3 over 2x times 6 is going to be minus 9. And then another minus 9 will be minus 18x. plus 36 minus 13 equals 0. So all I did there was expand the bracket, right? If you're not confident or comfortable with expanding, it's quite I guess the fraction does make it nasty. Remember, you can always expand the bracket somewhere off to the side and do it step by step. So I could have done a minus 3 halves x add 6 times by another minus 3 halves x add 6. And then I expand it right term by term, right? So I can do it a bit more. I can do it a bit more carefully, right? If I wanted to expand the bracket, and then you should get this expression, okay? If you expand it correctly. Anyway, so now we've got to that point. So we expanded the bracket, and then we've got this. We can then simplify some stuff. So then x squared plus 9/4 x squared is going to get me 13/4 x squared minus 18x. Add 36 minus 13. It's gonna get me plus 23 equals 0. I guess I can make it a little bit tidier by getting rid of the fraction part here, but just timesing everything by 4 to get rid of the fraction because it's out of 4. So then I'm going to get 13x squared, then minus 18 times 4 gets me minus 72x, then 23 times 4 is 92. And then I can perhaps just solve by the formula. So then I can say x then is going to be 72 plus or minus the square root of minus 72 all squared minus 4 lots of 13, 92, divided by 2 lots of 13. So just using the quadratic formula to solve this quadratic equation. So then I get that therefore x is going to be 46 over 13 or 2. Okay, quite nice number, so I'm kind of reassured that I might be on the right path here. So there we are, my two values of x. But again, we're solving the simultaneous equations, so now we need to find the y value. Well, I know y is this. Y is minus 3 halves x at 6. So therefore, then if I substitute these two values of x in, so firstly, if x is 46/13, then y is going to be minus 3 halves of 46 over 13. For x, add 6. And then that will get me at 9 over 13. Okay. And then alternatively, if x is 2, then y is going to be minus 3 halves of 2 add 6, which would get me 3. Okay, cool. So then therefore I got so then overall I got the point, I got these two coordinates then. So B could either be the point xy, where x is either 46 over 13, then the corresponding y is 9 over 13. Or if x is 2, then y is 3. So these are my two solutions to that equation, to those simultaneous equations, okay? So remember, we looked at how we solved quadratic simultaneous equations earlier on in the course, and indeed at GCSE as well. But I used it I solved by substituting, right? So I rearranged y, substituted it into the quadratic equation, then I solved x, then I got the y values. So those are my 2 points for B then. But the question then said to find the vector O to B, so the position vector of B. So remember, then the position vector of B, if I have the coordinate xy, then it's just going to be xi and yj. Or, as a column vector, xy, right? That way. Okay? Pick your fancy, but obviously we need to, at the end, again, in I and j form there. But then, if we have the 2 points then, as we said, if we know the two xy points in B, then we know that the position vector of B, so the vector form of the coordinate, right? So these two coordinates as vectors, we're either going to get x is 46 over 13 I, add 9/13 j, or the other possibility is 2i add 3j. So the x and the y parts there. And so there we are. So those are my two possible coordinate vectors for OB. So two possible position vectors there. So again, hopefully that just illustrates, to not overcomplicate it, just literally that the position vector, right, the position vector from the origin to a point, say B, is literally a coordinate of B in vector form. Okay, it's just a coordinate effectively. So we can go, so then we can use X and Y. Okay. Right, now we're going to finish off with an exam question, and I did say it's very similar to an earlier question, and I do recommend you do get to grips with these sort of questions. This question here, very bog standard, but yeah. So we're given that the point A has position vector 4i minus 5j, so position vector of A is going to be O to A, which is 4i minus 5j. And the point B, so the point, right, the coordinate of B, the position vector, so O to B, is minus 5i minus 2j. We then need to firstly find the vector A to B. Right, so again, I can do this. I can do this very quickly by recognizing when we looked at the fact that we can use position vectors if we have the vector from A to B, so point A to B, it's going to be the position vector of the latter one, so O to B, take away the first vector O to A, okay? And so if I do that, then my OB is minus 5i minus 2j, take away the vector A, so 4i minus 5j. So then if I then do the I and j's, so minus 5i minus 4i is minus 9i. And then minus 2j minus 5j is a double negative, be a positive. So minus 2j add 5j would be plus 3j. And there we are, that's my vector AB. Then it needs to then it says find the magnitude or the length of AB, right? So now we found the vector AB, we can find the length of it, right? In the same way that we looked at last time. So there again, that's going to be the root of the x or the I and the j part. Oh, that should be a j there. Okay, a j. So it's going to be the square root of the I and the j part squared. So that's minus 9 all squared. Add 3 squared. So then if we put that in the calculator, we get 3 root 10, and again the calculator will give you the fully simplified answer for a third. So yeah, that's fully simplified, and again that's 2 marks. You'll get a method mark obviously for doing that, for stating that root to show what you're doing. So you get a method mark, and then your final accuracy, your final mark there. You do not need to do any further you don't need to show any further simplifications. And so yeah, you will get all the marks here if you just do that, be rest assured. But yeah, so okay, so that's position vectors. So again, literally the main point, the position vector is just a coordinate of a point but in vector form. Okay, so yeah, so that's position vectors. I'll see you next time.